Hey guys, in this video I'm going to go through how you can derive the 8 inches per mile squared formula. If you didn't know, the 8 inches per mile squared formula tells you how quickly the Earth's surface drops away from a horizontal line. So if I draw a horizontal line right here, like so, it has a certain length L. There is a drop here, by which we mean a perpendicular line that hits the surface of the Earth. And the question that the 8 inches per mile squared answers is, given the length of this horizontal line, how large is the drop, d? So to get to the answer of this, we have to add some more to this construction, and we'll go through how to derive it. It's a pretty simple result. So first I'm going to show a radius of the Earth, like so. And I'm gonna create a parallel line to that horizontal, just offset a little bit down here. So this parallel line is of course gonna be of the same length because all the angles here are 90 degrees. And we're gonna have a drop here as well. So one more line remaining, that's another radius, like so. I'm gonna write R here for the radius of the Earth. And what is the last side of this triangle being? Well, we have here the radius of the Earth, and the side of this triangle is a little bit shorter than that. It's d shorter than r, so we're going to write here r minus d. Okay. So now we have established or constructed a right angle triangle. And the sides of this right angle triangle relate the radius of the Earth with the drop and with the length of this horizontal line. And so by using Pythagorean formula, then we can relate all of these together. Okay, so we're going to write out Pythagoras theorem, r squared equal L squared plus r minus d squared. And what we want here is an expression that tells us how much is the drop per distance squared. So we want to get d and L squared separate. I'm just going to start here by expanding this expression. We get L squared plus R squared minus 2RD plus D squared. Now we notice these two are the same, they cancel out. And I'm going to move, for now, just going to take, I'm going to make the observation here that we have the variable d is both squared and non-squared. So to actually solve this exactly, we would have to use a quadratic equation. But in this case, we're going to use an approximation instead. So we're going to make an assumption that the drop, right, we're going to write that, assume that d is much less than r. So, of course, it follows that d times d is still much less than r times d, right? Multiplying by both sides won't change this assumption. And what that means is that d squared here, the term, is going to be much less than the 2rd, and so it's not going to have any significant effect on the result. It's going to be too small, and we're approximating it to 0. So if I now write what I have 2RD is approximately equal to L squared. Okay. Now I can collect distance. I can collect the drop per distance squared on one side, D divided by L squared, and I can move the 2R over to the other side, so I get D divided by L squared is approximately equal to 1 over 2R. Now this equation tells us how many meters per meter squared the drop is, or how many centimeters per centimeter squared the drop is. As long as we use meters or centimeters, or the respective unit for the radius of the Earth inside here. But we want to have the result in inches per mile squared. So we need different units, so we need a conversion factor inside. And so to deal with that, I'm going to insert some units. We want this one to be in inches per mile squared. All right, mile squared. And we need to add that on the other side too, to be consistent. Inches per mile. And I'm going to split up the mile squared here. You'll see why. And like so. So from the way I've written it, we recognize that inches per mile, that's a fixed number, right? That's a given, how many inches there are in a mile. And this number, the radius of the Earth in miles, that's also a number we can look up. So when I write this out, we get the number of inches per mile, that's 63,360 inches per mile, and divide by twice the radius of the Earth in miles. That's 2 times 3958.8 miles. Now, we plug this into our calculator. What do we get? Well, we get 8.0024 inches per mile squared, which is pretty much 8. So now you know why there are 8 inches per mile squared. Thanks.